Okay, continuing on here. Patrolling AI using waypoints. So I've got this other scene here that has this fairly complex world. It's a terrain, so I'm using the slope feature of NavMesh to make unwalkable steep slopes. I have an unwalkable pond here, and I have a high cost area here. And right here at this gap between the walls, I've got another little high cost region. And over here, I have a animated wall that's going to open and close. And so if I play this, uh, my character will find the shortest path. Uh, Notice it will get as close as it can to this puddle of water and go around it. It'll come up around this, and it'll go around it if it has the option. But because it is walkable but just high penalty, it won't. It will enter it. So down here with this gate that's opening and closing, if I go back and forth here across this high cost gap, at some point that wall's going to open. It's thinking, and it's decided, oh, okay, it's cheaper for me to go this long way around. It really has to think a lot sometimes as that thing changes. This is changing the mesh, and it's recalculating it all the time. So it went that long way around because the gate was open. It'll cross that high cost area, but now as this gate's opening, it's thinking, oh, okay, I can go this way. I'll go the long way around. It really doesn't decide until the gate closes for sure. So anyway, this is an example uh, uh, with uh, uh, waypoints. Now, before I do that, here's a wandering AI. Uh, uh, this one is just going to kind of throw random positions around the world. It then goes to these randomly selected positions. Um, I've set up uh, uh, a line renderer that shows the calculated NavMesh path. These are thrown kind of randomly, so this character is going to wander all over the world, going randomly to different places. And we can do the same thing with waypoints. So if I have uh, uh, waypoints, now I have a whole bunch of waypoints. Uh, uh, here I have these waypoints scattered around the world, and I can um, uh, all I have to do to go to these waypoints, I use the set destination, new position, or I can set the agent's destination to be the new position. Either of these work. And so as I'm traversing around my waypoint circuit, if the agent's remaining distance is less than its stopping distance, that is, it's gotten to its waypoint, I'm going to increment the number, uh, uh, modulus it to wrap around to 0 again, and catch its transform position and assign that as the agent's destination. I could also set a randomly selected waypoint, in which case it would go all around the world. So with this one, this is going to go from one waypoint to another around whatever waypoint circuit you want the thing to have. There is a little gate here that's opening and closing and may at some point affect its choice as to which way it's going to go. And I believe the gap here also has a high cost region that it's going to try and go through. So I'll let you play with that, and you can see it's closed. So it had to just recalculate and go back around the other way because that gate closed before it could get there. Here's a, just for your amusement, here's a whole slug of wandering AI. Whoops. Here's a whole slug of wandering AIs. Lots of them, all going different places and throwing random points that each one of them has to go to. And they're all navigating on that NavMesh. The gate is opening and closing. This is a high cost region. This is unwalkable. This is a high cost region. And so lots of fun, lots of characters doing lots of funny things. I use the NavMesh modifier on the water discs that I put around the scene. One of them was non-walkable, another one was just hard, that had a higher cost. And the diagnostic script show route provides information for the UI showing various agent parameters. Path status, is path stale, agent has path, is on NavMesh, path is pending, and the path status, as well as using a line renderer that displays the path. I also explicitly calculated the remaining distance, since agent remaining distance only is finite when you get close to the destination, otherwise it's infinity. So with an agent path, I can loop through the different path corners as it navigates around these little triangles. It has path corners, and I accumulate the distance. And those path corners are also what I use to set the position count on my line renderer and to set the positions on my line. And that's what's displayed there as these characters traverse around through the scene. The line that's showing the path that it's going to take as it goes from one corner to the next. I'm going to stop again, and I'm going to come back and look at a procedurally generated maze. And this one's pretty cool. So I'll stop sharing here, and I'll end recording, and I'll see you in class. Bye.